And it is once again sleepwalking time. To recap, we've got the claim that exactly 30% of adults sleepwalk. So we've got our null hypothesis that that is true. And our alternate hypothesis, our testing really, is going to be that that's not the case. So we're working from the assumption it is true, and we want to see what happens. We've picked our critical value. We always do that before we start crunching numbers. And now we've done our sample. We've got a real data. We've got 27 randomly picked adults. 5 of them have sleepwalked at some point in their life. Don't ask me how we know who has and who hasn't. Magic has happened. We somehow know this exactly. Let's now calculate the p-value using the test statistic. So remember, the test statistic for proportions is given to you by this equation. Just like all the other equations in this class, do you need to memorize it? No. It's too similar to other equations. It's not worth memorizing. But we do need to know how to crunch the numbers properly. So let's see here. We'll use the proportion for our test statistic using p hat minus p over root pqn, where p hat is based on our sample. Our sample proportion is 5 over 27. Our population proportion based on the null hypothesis is 3, or 0.3, sorry, which means the complement to that is 0.7. Of course, our sample size is 27. We take these values, plug them into our equation, and we get a z-value of negative 1.302. This becomes a z-score. We will now do a lookup on the z-table using this z-score to find our region. Right, so if I look up z about negative 1.3 on a z-table, I get 0.0968. That's what I get there. Which means, hang on, this area right here is what I just said, 0.0968. But remember, we also said that we're okay with the right tail as well. Because, right, when we're doing strictly less than or strictly greater than, we content ourselves with just one area. But since we said not equal, that means we can do a less than or a greater than. So we basically double the area in question here. Right, one for the left-hand side, one for the left tail, and the other for the right tail. So in all, we're getting a p-value of 0.1936. Which means, again, several things. Among other things, it means that the probability of obtaining results is least extreme from the extended sample is about 20%, which is pretty big. But if you want to use technology, I've got some links for you here. I will share those links with you guys. You can use online calculators to find these results. Obviously, make sure they're giving you the right results. Also, make sure that you're giving them the right inputs. So again, for this 30% claim here, I've got my H0. That's my null hypothesis, that it is exactly equal to the hypothesized proportion of 30%. My alternate hypothesis, again, was not equal to, allowing for both greater than and less than cases. My sample size is 27. My favorable cases, the number of people who were sleepwalking was 5 out of 27. And my ascribed significance level. So all of those things, instead of me crunching the numbers, I give to my machine overlords, and my machine overlords crunch those numbers. And you will find the same p-value. And then also, because of the internet being what it is, a lot more than that. Technology, if you can use it right, will do you some pretty good stuff. If you do it wrong, it will not do you well. The saying garbage in, garbage out comes to mind. You put in the right stuff, you'll get the right stuff out. Don't do it, it won't happen. All right, and we're just about there. We've got our p-values now. All we have to do now is make good conclusions. I'll see you in the next video.